Hey everybody, it's Mr. Kamosi here. Welcome back after an unusual spring break. In FOM 11 here, we are starting a new unit, trigonometry, and so today we're going to do lesson 1. I'll send you these notes. If you could print them out and then maybe copy down the lesson, that would be great. And of course, the exercises are at the end of this lesson with an answer key for you to work on. So here's trigonometry lesson 1, the Pythagorean theorem. I'm going to call mine answer key. Now some of this might be a little bit of review from last year. We are going to review some basic trigonometry and then we're going to get into some new stuff that's part of Foundations Math 11 called the sine law and the cosine law. Okay, but for today it's the Pythagorean theorem. And it says this: trigonometry is the mathematics involved in studying triangles. Triangles have been used for years in engineering and architecture and therefore warrant a specific branch of mathematics devoted to them. Pythagoras was a famous Greek mathematician who lived in the 6th century. He and his followers, the Pythagoreans, studied many properties of numbers and geometric figures. The most famous discovery made by Pythagoras was the relationship between the side lengths of right-angled triangles. That should say right-angled right there. First, let's name the sides of a right-angled triangle. The one that's across from the 90-degree angle is given the letter C, and it's actually called the hypotenuse. And you can see in this bubble over here, it reiterates that the side opposite the 90-degree angle is called the hypotenuse. It is given the symbol C. The other two sides are called legs. They are given the symbols A and B. Okay, so it doesn't matter which one you choose for A and which one you choose for B. I often call this one A and this one B. And these are called legs. So that's a leg, and this one is a leg. The Pythagorean theorem is given by the simple formula seen below. A squared plus B squared equals C squared. Or you can write it like this: C squared equals A squared plus B squared. I often write it like that if we're actually trying to find C, because then C is on the left-hand side of the equation, and we often like to have that when we're solving for an unknown letter. Now let's try to use the formula to find the missing hypotenuse or a missing leg. Okay, so we'll start off with the more straightforward case, which is finding the hypotenuse. And example 1 says find the missing side. Okay, and so remember, across from the 90-degree angle, that's your hypotenuse. So that's the side that we label C. And that's really the most important one to determine, because C is the one that's by itself in the equation. Okay, and so A and B, it doesn't really matter which of the other two sides that you label A and B, just as long as you have C in the right spot. Okay, so we could call this one A and this one B. Those are the legs. All right, and we're trying to find that missing side, which they've called X, but we can now call it C. And the Pythagorean theorem says that C squared is equal to A squared plus B squared. And if you want to, you could say, hey, C has really been called X, so we could put X in there and say X squared is equal to A is 56, 56 squared plus B is 33, 33 squared. Okay, and so what we need to do now is get X by itself. So right now it's X squared. Okay, and what we can do then is work out that number on the right hand side. So I will get the virtual TI out. There it is. And we will go 56 squared plus 33 squared. Press enter, so 4,225. All right, the way to get x by itself now is we have to do the inverse operation of squaring. X is being squared right now. That's what that 2 means. And the inverse operation of squaring is square rooting. So what you have to do is square root that. If I square root x squared, I will get back to x. And whatever you do to the left-hand side, you have to do to the right-hand side. Okay. And technically, guys, when you solve an x squared equation, the positive or negative answer would work, because if you square a positive, you get a positive number, and if you square a negative, you get a positive number. So we actually have to put plus or minus in front of that. Okay, and then we decide which one to use based on the context of the question. The square root of x squared is just x, and the square root of 4,225 is 65. So we get an answer here of plus or minus 65. But if we look at the problem, we're trying to find the length of a side of a triangle. And so it doesn't make sense to call that negative 65 centimeters. So we would reject the negative answer and we would just say that x is equal to 65 centimeters. And there's our final answer. All right, let's try example 2. A rectangular lot has dimensions of 16 meters by 28 meters. Find the length of a path that runs diagonally across the lot. Okay, so we have this rectangular lot like this. It is 16 meters by 28 meters. And it wants us to find the length of the path that runs diagonally across the lot. It wants us to find this. Okay. And so hopefully you can see that we have now made a 90-degree triangle. There's the 90 degrees. And across from the 90 degrees is the side we label C. So there's C. A is 16 and B is 28, and we can use the Pythagorean theorem to solve for C. Pythagorean theorem says C squared is equal to A squared plus B squared. So C squared is equal to 16 squared plus 28 squared. And if I do 16 squared plus 28 squared, I get 1,040. Okay, and of course at this point, to get C by itself, I have to square root both sides, and I square root that, and I note that the positive or negative could work. Okay, and then I go, the square root of C squared is just C, equals plus or minus the square root of 1040 is, let's round to one decimal place, 32.2. And this time it is going to be in meters, because notice that the other two sides are in meters. And we're going to reject the negative answer because we can't have a negative length. So we'll go 32.2 meters. And that is how you do example 2. All right, next page. How about finding a leg? So we did a couple of examples of finding the hypotenuse. Now we will try to find a missing leg. Let's look at finding a missing leg. So example 3, find the missing side. Okay, and so again, across from the 90 degrees, that's the hypotenuse, which is C, and you can label the other two sides A and B in any order you want. I just happen to label them that way. And so this time we will go a squared plus b squared equals c squared. And the reason I wrote it like that is because we know c, and our unknown letter is actually now on the left side of the equation. Our unknown is b, right, because it's labeled as x. So a is 55, so I put 55 in for a. B, they've called x, so we could write x squared. And c is 73, and we have to solve this little equation. So let's first of all work out some of our numbers. We have 55 squared, and that is 3025. Plus x squared equals, and then we have 73 squared, which is 5329. All right, and we have to get x by itself. X is being squared, and then we're adding 3025, so I have to do the exact opposite of all of that. So I have to subtract 3025 from both sides. Over here it cancels to 0. And you notice that we have positive x squared, so I'm going to go x squared equals 5329 minus 3025, and I end up getting 2304. And I'm just going to move this over to the right a little bit, because at this point, how do you get x by itself when it's being x squared? You have to square root both sides. So we go square root both sides, put the plus or minus, and we end up getting x equals plus or minus the square root of 2304. Press equals, hey, 48. And we look and we go, what is x? It's the length of a side, so I'm going to reject the negative answer. The negative works mathematically in the equation, in the original equation, but it doesn't make sense for the real problem. And so we would just say x is equal to 48 centimeters. And that is finding a missing side. All right, let's try example 4. A 5.3 meter ladder is leaned against a wall so that the foot of the ladder is 1.2 meters away from the base of the wall. Find how high up the wall the ladder reaches. Okay. So let's call this the wall. And here's the floor. And there's the ladder. And it says it's a 5.3 meter ladder, so I'm going to write this in as 5.3 meters. And I'm just going to give us a little extra space here. Okay, and so this 5.3 meter ladder is leaned against a wall so that the foot of the ladder is 1.2 meters away from the base of the wall. So here's the foot of the ladder, kind of means the bottom of the ladder, and the base of the wall is kind of the bottom of the wall. And it's saying that the foot of the ladder is 1.2 meters away from the base of the wall. So there's our triangle. Here's our 90 degrees. And it wants to know how high up the wall the ladder reaches. So there's where the ladder is touching the wall. We want to know this height, ultimately. We could call it h or x or whatever. Okay, so now that we have our triangle, we know two sides of the triangle, and it's a 90-degree triangle, and we know that across from the 90 degrees is C, the hypotenuse. The other two sides can be labeled A and B, so let's make this one A, and we could call this one B. And our Pythagorean theorem says that a squared plus b squared equals c squared. So a is 1.2, so let's go 1.2 squared plus h squared equals 5.3 squared. Okay, and then it's just a matter of getting h by itself. So let's work out the numbers. 1.2 squared is 1.44 plus h squared equals 5.3 squared, which is 28.09. And we have to get h by itself. So I have to subtract 1.44 from both sides. And so h squared is equal to 28.09 minus 1.44, which is 26.65. And then from here, to get h by itself, I'm going to go square root, and the answer can be the plus or minus of that. In the original equation up here, positive h or negative h would work, because see how it's h squared? So if you square a positive or a negative, you're going to get the same result. So that's why the negative works as well. Okay, but the positive is the only one that makes sense in these contexts, because we're finding the length of something. Okay, so the square root of h squared is h, and the square root of 26.65 is 5.16 and a bunch of stuff, so why don't we round that to one decimal place and we'll say 5.2 meters. And actually, technically, we need that plus or minus in there first, so h is plus or minus 5.2. And then I would say h is equal to 5.2 meters in the context of the problem. Okay, and so that is finding a missing leg. Finally, let's look at some problems that require more than one step. So example 5. A ramp is placed on two cement blocks that are 1.2 meters apart. If the blocks are 2.3 meters and 4.1 meters high respectively, find the length of the ramp. Okay, so we have a cement block here, and we have a cement block here, and it is saying a ramp is placed on two cement blocks that are 1.2 meters apart. So the ramp is like this. It's going from this cement block to this one here. Okay, and the two cement blocks are 1.2 meters apart. So this is 1.2 meters. If the blocks are 2.3 meters and 4.1 meters high respectively, find the length of the ramp. So let's make this one, obviously this is the 2.3 meter high one, and this one is 4.1 meters. So how are we going to form a 90-degree triangle? Because that's ultimately what this section is about, Pythagorean theorem, and we need a 90-degree triangle. So what we're going to do is see the 1.2 meters apart, that dotted line, that can actually shift up to here. This is 1.2 meters as well. Okay, we want to find the length of the ramp, which is this C value here. I know that's C because here's the 90 degrees, and across from the 90 degrees is C, and this is the ramp. So that's the length that we want to find. So we also need to know what this length is right here. Okay. And you may notice, guys, that this length right here is the difference in height between the two cement blocks. Okay, so this length is 4.1 meters minus the 2.3 meters. Okay, which is 1.8 meters. Okay, so now that we've established that, maybe I will erase that calculation and I'll just put that side length is 1.8 meters. The difference in height between the two cement blocks. And now we can solve for the length of the ramp, C. Okay, and since we're solving for c, I'm going to write the Pythagorean theorem as c squared equals a squared plus b squared. I'm just going to go back to blue here. Okay, so c squared is equal to, let's call this one a and this one b. It will be 1.2 squared plus 1.8 squared. And so c squared is equal to, I'm going to do that calculation all at once, 1.2 squared plus 1.8 squared, and write down 4.68. Okay, and as usual, to get c by itself, we go square root, could be the plus or minus, because positive or negative will work in the original equation. C is equal to the square root of 4.68, bang, which is about 2.2 if I round to one decimal place. So plus or minus 2.2. And we would say, therefore, c is equal to, let's just take the positive because it's the length of the ramp, 2.2 meters. Okay, because our other dimensions are in meters. All right, and finally, example 6. In the diagram below, AD is equal to 26 millimeters. So if you go from A down to D, they are saying that that is 26 millimeters. BD is equal to 31.5 millimeters. So B all the way to D. They're saying that that is 31.5 millimeters. And then AC is 10 millimeters. So this guy is 10 millimeters. Find AB. Find AB. So they want us to find this length over here, which I'm going to label C. They want us to find that. Okay, and I've labeled that C, guys, because notice that there's a 90-degree angle box right here, and if that's 90 degrees, then the angle right beside it has to be 90 as well, because they're sitting on a straight line, so they have to add to 180. So they're both 90. And you can see that we have two 90-degree triangles. So our plan of attack is this. We're going to use the triangle on the right here to figure out this length here from C to D. We'll call it X. And then since we know that the whole big length is 31.5 millimeters, I'll go 31.5 millimeters minus that X that we get, so that we can get this side, BC, we'll call it Y. And then once we have BC and the 10 millimeter side there, we can go A squared plus B squared equals C squared in the 90-degree triangle on the left. Okay, so first things first, let's figure out X. And remember, across from the 90 degrees, we would label that C, right? And so I would go like this. Oh, and then we can label our other two sides. We can call this one A and this one B. So A squared plus B squared equals C squared. The A is X, so we will call it X squared, plus B is 10 10 squared equals C is 26 squared. So let's work out some numbers. 10 squared is of course 100, 26 squared is 676. So we have x squared plus 100 is equal to 676. Then I would subtract 100 and subtract 100. And get x squared is equal to 576. And then I need to go square root. Square root could be plus or minus, but we know we're just going to use the positive because we're finding the length of a side. And so x is equal to the square root of 576, okay, which is 24. Nice. 24 millimeters. Okay, so this is 24 millimeters. And we know that from D all the way to B is 31.5 millimeters, so we can say therefore that side length y is going to equal 31.5 millimeters minus 24 millimeters, which is 7.5, right? 31.5 minus 24 is 7.5 millimeters. So y is equal to 7.5 millimeters. Okay, and now we can do Pythagoras in the triangle on the left, the smaller triangle on the left there, using this as our A, and this is our B, and then we're trying to find C, which is across from the 90-degree angle. So here's what I'm going to do. I'm going to go y equals 7.5 millimeters. And I will label the triangle like this. Across from the 90 is C. Nice. And we already called this one B from before, so we'll call that one B. And then this is A. So I'm going to go C squared C squared equals A squared plus B squared in the small 90-degree triangle. C is what we're trying to find. A is 7.5, so I'm going to go 7.5 squared plus 10 squared. So C squared is equal to 7.5 squared plus 10 squared. Press enter. 156.25. And actually I better give myself a little bit more space there. Square root both sides to get C by itself. C is equal to the square root of that, which is 12.5. So I mean, technically, mathematically, plus or minus 12.5 works, but we would say therefore, since C is the length of a side, C is 12.5 millimeters. Okay, and that is equal to the side AB, which is what we were trying to find. Okay, so there are the notes, everyone. That's our first lesson for trigonometry. Here is the assignment. Lots of practice questions for you to try. So have a look at these. You can see there's a good amount of questions in the notes. And at the very end, guys, there is an answer key to help guide you. If there's any problems with that, or if there's any that you want me to show you how to do, maybe just fire me an email and I can do another video of some homework questions and I can post it for you. Okay, so I won't ask you to hand this in. You don't have to return it back to me or anything like that. You have an answer key here to guide you. But yeah, if you do have questions, let me know, and I'll see if I can post some more videos showing you how to do the homework. Okay, when we get to assessments, I may send you the odd quiz, but I'll be sure to let you know, hey, this is definitely one you have to hand in, and if we do get to a test, I'll send you the test. It can be open book, you can do it at home, and then send it back to me. Okay, but I'll let you know more about that if that happens. There you go. So there's your first video, and here's your first assignment with answer key. That's all you have to do for this week, and I will post another one next week, and we'll just do one contact each week like this for as long as we're doing online learning. Okay, there you go, my children. Good luck, and let me know if you have any problems. Talk to you soon.